Good morning, students. I am Dr. Masud Reddy, Associate Professor of Chemistry, working in Molar Science College, Mysore. Today, we will be discussing about stoichiometry, which is a part of the syllabus of first semester students of Molar Science College, Autonomous, Mysore. As you all know, ours is an autonomous college, so we have our own syllabus. And in the first semester, stoichiometry is under general chemistry topic. As you know, there are 4 hours per week, one class for organic chemistry, one class for inorganic chemistry, one class for physical chemistry, and one class for general chemistry. So under general chemistry, you have a chapter named stoichiometry. So this is just a repetition of what you have studied in your PUC. In PUC, you have studied a chapter called Basic Concepts of Chemistry, Unit 1, or Part 1 of for 11th standard. So, there you have studied laws of chemical combination, scientific notation, significant figures, then concept of atomic mass, molecular mass, molar mass, then concentration terms, molarity, mole fraction, etc. So it is just repetition of what you have studied in your first PUC. So before we go to the details of the syllabus under stoichiometry, let us see what is stoichiometry and why these topics, namely atomic mass, molecular mass, mole concept, concentration terms, significant figures, etc., are called as basic concepts because these are the concepts which one should know as long as one studies chemistry. That's why these concepts are called as basic concepts of chemistry. So stoichiometry is also one of the basic concepts of general chemistry. So what is stoichiometry? Stoichiometry is a branch of chemistry that deals with the quantitative study of the reactants and products in a chemical reaction. So what is stoichiometry? Stoichiometry means it's the quantitative study of the amounts of reactants and products in a chemical reaction. ಅಂದ್ರೆ ಏನು ಒಂದು ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ತಗೊಂಡ್ರೆ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಎಷ್ಟು ಕ್ವಾಂಟಿಟಿ ರಿಯಾಕ್ಟ್ ಆಗ್ತಾ ಇದೆ ಎಷ್ಟು ಪ್ರಾಡಕ್ಟ್ಸ್ ಫಾರ್ಮ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. So in order to carry out quantitative study of the reactants and products in a chemical reaction, it is necessary to use a balanced chemical equation. ಏನು balanced chemical equation ಅಂದ್ರೆ so, balancing of a chemical reaction is done based on law of conservation of mass. You have studied in PUC or even high school that law of conservation of mass states that matter is neither created nor destroyed, but one form of the matter can be converted to other form. For example, solid can be converted to liquid, a liquid to gas, or gas to liquid, or solid to vapor directly. So this is nothing but conversion of matter one state to the other physical state. So according to this law of conservation of mass, it is necessary to balance a chemical reaction. So what is balancing a chemical reaction? In the sense, the number of atoms of each element present on the reactant side should be equal to the number of atoms of that element on the product side. For example, if we take up barium chloride plus H2SO4 giving rise to barium sulfate plus water. If you consider this reaction, so balancing a chemical reaction is nothing but the number of atoms of each element on the reactant side should be equal to the number of atoms of that element on the product side. For example, here we have one barium atom on the reactant side, one barium atom on the product side. We have 2 chlorine atoms here. Oh, sorry, I'm still sorry. So it is a 2 HCl. So we have 2 chlorine atoms here. So here we have 2 chlorine atoms. Then we have 2 hydrogen atoms here. 2 hydrogen atoms. one sulfate ion, the other sulfate ion. So the number of atoms of each of the elements are present on the reactant side is same as the number of atoms of that element present on the product side. So this is called balancing. Similarly, if you take up another reaction, so the reaction is an acid-base reaction, of course, carried out in aqueous medium. So we have sulfuric acid reacting sodium hydroxide, give rise to sodium sulfate and water. So here also, when we look at the number of hydrogen atoms here, on the reactant side, we have two here, two hydrogen atoms, totally four. We have four hydrogen atoms here. Then you have four oxygen plus two, six oxygen atoms. 4 plus 2, 6 oxygen atoms. Then you have one sulfur atom here, one sulfur atom here, and two sodium atoms, and two sodium atoms. So like that, we balance a chemical reaction according to law of conservation of mass. So this mass is conserved in the case of chemical reactions, but in the case of nuclear reactions, like nuclear fission and fusion, there is a change in mass. So there's a concept called mass defect. Means the masses of products will be slightly less than the masses of reactants taking part in a nuclear reaction. So that difference in small amount of masses of the products from that of the reactants is called mass defect, and that mass defect is converted to energy. That's the reason why in the case of nuclear reactions, namely fission and fusion, enormous amounts of heat is released. Whereas in the case of chemical reactions, where the nuclei are intact, only small amounts of energy is released, and the masses of the reactants will be equal to masses of the products. Whereas in the case of nuclear reactions, the nuclei themselves undergo reaction, undergo a change. Thus they are called as nuclear reactions. I repeat, in a chemical reaction, the nuclei are intact. It's only the valence shell electrons which take part in the reaction. So here, you have barium chloride reacting sulfuric acid. These are the atoms present here on the reactant side. In the product side also you have, on the product side you have barium atom, sulfur atom, chlorine atom, hydrogen atom, which indicates that the nuclei are intact. So in the case of chemical reactions, the mass is conserved, but not in the case of nuclear reactions, because nuclear reactions are always accompanied by mass defect. So that disappearance of mass is released in the form of energy. Right. So these are the examples of reactions, balanced chemical equations. As I said, which is necessary, balancing is necessary in accordance with the law of conservation of mass. So when you look at this equation, which is balanced, so what information do we get from the balanced chemical equation? Because, as I said, stoichiometry is nothing but quantitative study of the reactants and products involved in chemical reaction. So, in stoichiometry, we measure or study the amounts of reactants and products taking part in a reaction. So, this stoichiometry, the term stoichiometry is derived from a Greek word called stoichion, which means an element. Metros means measure. So, the term stoichiometry derived from Greek means the measurement of elements. So, what is this measurement of elements? What are we measuring? We are measuring the quantities of reactants and products involved in a chemical reaction. So, when we have a balanced chemical equation, Because in order to study the quantities of reactants and products involved in a chemical reaction, it is necessary for us to have a balanced chemical equation. So what information do we get from a balanced chemical equation? So if you consider this, which is balanced, so this indicates that 1 mole of barium chloride reacts with 1 mole of sulfuric acid to give 1 mole of barium sulfate and 2 moles of hydrogen chloride. Since this reaction is performed in aqueous medium, means the solutions are prepared in water. So these indicates the terms written in the bracket indicate the physical state of the reactants and products. When I write barium chloride AQ, it is aqueous barium chloride solution. In the sense, barium chloride dissolved in water. H2SO4 aqueous, we prepare sulfuric acid solution of different required concentrations in water, and this downward arrow mark indicates that it is the precipitate which is formed. Barium sulfate is a precipitate. Why a precipitate is formed? Whenever a substance is insoluble in the medium, then that will separate as a solid. So that's called precipitate. So barium sulfate is precipitated, and you have HCl dissolved in water, hydrochloric acid. So this is the information that we get. So one way of stating the quantities of reactants and products involved in chemical reaction is that it could be in terms of moles. In this case, 1 mole of barium chloride reacts with 1 mole of sulfuric acid to give 1 mole of barium sulfate and 2 moles of HCl, provided the reaction is 100% complete and provided all the reactants are in their purest form. So also, if you consider a gaseous reaction like what's a gaseous reaction? Where you have all the products and reactions in the gaseous state. Even this reaction is balanced. So this again states 1 mole of nitrogen gas reacts completely with 3 moles of hydrogen gas to give 2 moles of ammonia gas. So this is one way of dealing with quantities. The other way is we can also state it in terms of volumes. 1 volume of nitrogen gas reacts with 3 volumes of hydrogen gas to give 2 volumes of ammonia gas. This is one way. And this volume can be stated either in milliliters or liters. So when it comes to liters, you have been taught about the molar volume. What's molar volume? Volume occupied by a gas or vapor. Volume occupied by 1 mole of a gas or a vapor at a given temperature and pressure. That's molar volume. I repeat, what's molar volume? It is the volume occupied by 1 mole of a gas or a vapor at a given temperature and pressure. Why do we say at a given temperature and pressure? Because volume of the gas is not fixed. It varies with the temperature and pressure. You have studied Boyle's law and Charles' law. So, Boyle's law is that at a given temperature, volume of given mass of a gas varies inversely with the pressure. And Charles' law states that at constant pressure, volume of given mass of a gas varies directly with absolute temperature. So this is the Boyle's law and this is Charles' law. So from these laws we understand that volume of a given mass of a gas varies with the temperature and the pressure. Therefore, if you fix the temperature and pressure, then the volume of the given mass of a gas is fixed. So when I say standard molar volume, so standard molar volume is nothing but volume occupied by 1 mole of a gas or vapor at 273 Kelvin and 1 bar pressure. Earlier, they considered standard pressure as 1 atmosphere. Now, according to IUPAC system of notation and SI system, we consider 1 bar pressure. So, standard molar volume is the volume occupied by 1 mole of a gas or vapor at 273 Kelvin and 1 bar pressure. So, since you are fixing temperature and pressure, irrespective of the nature of the gas, 1 mole of any gas or any vapor occupies 22.7 liters at 273 Kelvin and 1 bar pressure. 1 bar pressure is nothing but 100 kilopascals, and 1 atmosphere is slightly larger than 1 bar. So, at 100 kilopascals pressure and 273 Kelvin, 1 mole of any gas or vapor occupies 22.7 liters volume. So, knowing this value, molar volume at standard temperature pressure, we can also write this in terms of liters. So 22.7 liters of nitrogen react with 3 into 22.7 liters of hydrogen gas to produce 2 into 22.7 liters of ammonia gas. So we can also state this quantities of reactants and products in terms of volumes without any unit, or in terms of liters also. As I said, this is the standard molar volume. So these are the volumes of nitrogen and hydrogen and ammonia involved in the reaction when the reaction is 100% complete. So also, when we are dealing with a chemical reaction in solution state, as I said, NA movement, aqueous, plus 2SO4, aqueous, giving rise to Na2, aqueous, plus water. This is the reaction. So since these are solutions, we can use concentration terms like molarity, normality, molarity, mole fraction, etc., which I'll be discussing about these definitions and quantities later. So, the other way of expressing the quantities of reactants and products involved in a chemical reaction is in aqueous state. I can also state this even 1 liter of 2 molar in a solution. 1 liter of 2 molar in a solution reacts with 1 liter of 1 molar sulfuric acid to give sodium sulfate. Because it is the, if I take 1 liter of this and 1 liter of this, so you get 2 liters of base solution, neglecting the volume of what is formed, because since in aqueous medium, this water is in a larger amount, neglect this volume, I get 2 liters of sodium sulfate, and what will be its concentration? It will be 2 liters of 1 molar sodium sulfate. So this is how, depending upon the physical states of reactants and products, different units for the quantities of reactants and products can be used. So this is what is called as stoichiometry. So I repeat, stoichiometry deals with the quantitative study of reactants and products involved in a chemical reaction. So before going over to the mole concept, which is the first topic of your syllabus, let us try to recollect what is atomic mass and what is molecular mass. Again, this you have studied under basic concepts of chemistry in PUC. So, as you all know, atoms and molecules are microscopic in nature. They are very small in size and they are not visible to naked eye. One molecule or one atom cannot be seen with the naked eye. So, the atoms and molecules are in microscopic state. So, very difficult to determine the atomic mass and molecular mass. Of course, nowadays we have improved mass spectrometric technique. With the help of it, we can determine mass of each atom. But in the 19th century, when the concept of atomic mass and molecular mass was introduced, because in the 19th century, the subatomic particles named electron, proton, neutrons were discovered, and atomic structure was given. So we know an atom consists of a nucleus at the center, comprising of protons and neutrons, and electrons revolving around the nucleus in orbitals. So once an atom has got electrons, protons, and neutrons, so it has got mass. So atomic mass in those days, when mass spectrometric technique was not known, was considered in comparison to carbon 12 isotope. I repeat, since the atoms and molecules are microscopic in nature, it is impossible to determine the mass of a single atom or a molecule. Therefore, in the 19th century, in order to arrive at the mass of one atom or mass of one molecule, different standards or references were considered. So the scientists, they considered hydrogen 1 as a hydrogen isotope as a standard, and they tried to calculate atomic masses of other elements, which was not successful. Then they tried with O16 isotope as a reference. So all other atomic masses were determined considering O16 as a reference. Even this had some anomalies, and ultimately the chemists considered C12 isotope as a reference. What's an isotope? Isotopes are the atoms of the same element having different mass number. In mass number is nothing but this number of the sum of protons and neutrons present in an atom. What's atomic number? Atomic number tells us the number of electrons or protons present in an atom. So, isotopes means they are the atoms of the same element having different mass number. When I say atoms of the same element, these isotopes will have same atomic number but different mass number. So, the difference in mass number is due to presence of the different number of neutrons. So, if you have considered isotopes of hydrogen, you have hydrogen, deuterium, and tritium. And so also if you consider oxygen, you have O70, O80 isotopes. Similarly, if you consider carbon 12, isotopes of carbon, C12, C13, C14. So these are the isotopes. So all these isotopes of hydrogen have atomic number 1, isotopes of oxygen have atomic number 8, isotopes of carbon have atomic number 6. But the only difference is in their mass number. If you consider C12 isotope, mass number is 12, there are 6 protons and 6 neutrons. C13, there are 6 protons and 7 neutrons. In C14, there are 6 protons and 8 neutrons. So that is the meaning of isotopes. So in the 19th century, the atomic masses and the molecular masses were calculated taking C12 as a reference. So C12 isotope is taken as a reference. And as I said, the atoms and molecules are microscopic in nature, that is invisible to eye and they cannot be separated and weighed. So carbon 12 isotope atoms weight is taken as 12 units. That is 12 AMU or 12 units. Nowadays we call it as unified mass denoted by U in the sense. 1 U is atomic mass unit. AMU is now denoted by U, unified mass. 1 U is 1.66 into 10 to the power minus 27 kilograms, or 1.66 into 10 to the power minus 24 grams. So, the scientists fixed the mass of carbon 12 isotope as 12 units. So, fixing the mass or assuming the mass of one atom of C12 isotope as 12 units, they tried to calculate atomic masses of all other atoms as well as masses of other molecules. So, according to the definition of atomic mass, so when I say atomic masses have been calculated considering C12 isotope as a reference, we call the atomic mass of the other atom calculated as relative atomic mass, because atomic mass of C12 is assumed to be 12 U. So whatever other masses are calculated, they are only in relation to the mass of C12 isotope. So whatever atomic masses and molecular masses that we use, they are relative atomic masses, or simply called as atomic mass. So atomic mass is defined as the ratio of mass of one atom of the element to 1/12 mass of C12 carbon, C12 atom. This is the definition of atomic mass. So, atomic mass is defined as mass of one atom, ratio of mass of one atom of the element to 1/12 mass of C12 atom. Since 1/12 is the denominator, this can also be written as into 12. And in the denominator, have only mass of C12 atom. So, this is called atomic mass. Similarly, molecular mass is defined as mass of one molecule of the compound divided by mass of C12 atom into 12. This is the definition of molecular mass. Right. So, this is how we define atomic mass and molecular mass. Based on this, in the next class, in the next session, we shall consider the concept of mole and molar mass. Thank you.